All right, we have 30 minutes only, so I want to start the presentation. One more time, welcome everyone to presentation. So the title is Mastering Efficiency in Argo CD, and we will be talking about what does it take to scale Argo CD and how much does it cost, and I will share with you, tips how to reduce your cloud bill. Before I start, quick introduction. So my name is Alexander Matyushentsev. Don't try to pronounce my last name. So I'm one of the Argo project co-creators. I've been working on this project for like 7 or 8 years, and I'm also a co-founder of a company called Akuity, where we run Argo CD for other companies. And in the last several years, we learned several lessons about how much money you have to spend to run Argo CD at scale, and I'm going to share these learnings with you and hopefully help you to save some money for your organization. Here is today's agenda. It's kind of simple. First, I want to basically convince you that this topic worth a conversation. So we all know that if you use Argo CD, you know it's cheap and very efficient until you have to run it at a really large scale. And so it can get expensive at some point, and I want to share with you some numbers of what expensive really means, so you can decide if it's time for you to invest, some effort into reducing the bill and optimizing. And I'm going to share with you some lessons we've learned and solutions that you can apply to reduce cost of your Argo CD. And now it's time to start. So I do want to start from the statement that Argo CD is, it's not going to cost you a lot from the beginning. So one of the most common ways to run Argo CD is to install it into the cluster that you plan to manage. And this is the screenshot of freshly installed Argo CD on a small cluster. And as you can see, we have quite a lot of pods, but combined they use a fraction of CPU and maybe 100 megabytes of memory. A couple of those pods are even optional, such as DEX and notifications controller. You don't even run them if you don't need to. And there is a diagram that shows how those components interact. And as you can see, there is basically 4 of them that you would need to install and pay for. And so generally, Argo CD won't cost you anything because highly likely it will just land on some nodes instead of your cluster that have spare memory and CPU, and Argo will apply a little bit of pressure on a Kubernetes API server of your cluster, but it's really hard to translate it to money, so basically it's kind of free. And so it's free until you decide to, use Argo CD more and use one of the most appealing features of it, which is called multi-cluster management. And so once you try to manage multiple clusters, you would have to change a bunch of things. And kind of high level, you would need to create a centralized control plane, which is used usually by multiple engineers in your organization to manage a lot of infrastructure. And there is a very important new requirement here, is that this control plane has to be highly available. And it's not very specific to Argo CD, but basically, if you have any application that has to be available all the time and it has to survive upgrades without downtime, you would have to start, run multiple instances of everything. And this is the same diagram that you just saw in a previous slide in a so-called HA mode. So if you're not aware, Argo CD has in official repository 2 installation manifests, and we highly recommend to use HA version of manifests if you install Argo CD in production. And the result is you would have to run multiple replicas of pretty much every component. So there is API server, repo server that serve requests. We need multiple replicas because to have a rolling update. We have one stateful component, Redis, and Redis turns from 1 pod into 5 pods. One is stateful set and HA proxy that balance requests. And you might end up having multiple controllers if you manage multiple clusters. And this transition also requires infrastructure that would cost you some money. I kind of try to highlight here, things that maybe not as obvious and will contribute to your cloud bill. So obviously we need instances to run Argo CD components. That's obvious. What's not obvious is we need at least 3, even if you have beefy instances with a lot of memory CPU. We need 3 of them to kind of satisfy all pod anti-affinity rules and run all components in HA mode. Next, not unpleasant surprise that you might realize a little later, it's not okay to reuse one of your workload clusters to host Argo CD as well. You might regret about it in the future, and the reason is sometimes other workloads on a cluster overload API server, and it affects Argo CD and other way around. So it's highly recommended to have dedicated control plane cluster, and the bill starts from several $100s a month just for HA API server, usually managed by your cloud provider, plus those 3 nodes that you need to have for Argo CD workloads. And so last but not least, you are going to have to pay for traffic. And it's kind of not obvious because if you use AWS, those costs will be hidden under this shy EC2 other section, but it's surprisingly big. Like in multiple cases, this network cost is around 30% of the bill. So it is significant, and as I will share a little later, sometimes it actually can spike, but there is a way to mitigate the cost spike. So next, I promise to share some numbers, and this is mostly for you to decide, at which point it makes sense to start looking at the cost. And so basically, we didn't want to guess, and we just ran an experiment to get some real numbers that we can then play with. And so this is description of what we did. We created a GCP cluster that we used as a control plane. It had 3 nodes, and we just chose this node size to make sure it fit a pretty big Argo CD instance that managed a lot of clusters and applications. Next, we installed Argo CD on it, and deployed 800 applications across 3 managed clusters, and we did not count cost of those managed clusters because those represent your workload clusters. And this is the result. This slide is mostly to prove that we did run it. We kept it for like almost a week, and later on we kind of took the most important numbers, and we've got this. So a long story short, the combined cost of that whole setup was around $40 a day. And so if you multiply it by number of days, you will see that if we kept it running for a year, we would have to pay around $11,000. And 30% of that cost was network traffic. I think one important detail, most of the traffic we had to pay for was over internet, and significant part of it was cross-availability zone traffic. And so our workload clusters were available to control plane over internet. So you might make it cheaper if you use, same VPC to connect all of your clusters. And then one way to extrapolate the results, I do realize this very kind of naive way to try to measure how much it would cost you if you have a bigger setup. But that's basically, it tracks very precisely with what we've seen from our experience. So you can basically, using this simple math, you can calculate that in our experiment at least, one Argo CD application cost us $1.49. And so this table is, I don't mean to scare you, but it kind of shows you the level of a problem. If you're trying to manage 3,000 applications, you might have to spend $50K a year on a control plane. And for 6,000, I didn't even want to put this scary 6-digit number. My main goal here is to convince you that at large scale, when you manage 6,000 applications, that usually translates to like close to 100 clusters, then control plane became quite costly. It's like comparable to a salary of engineer, and it does make sense to start worrying about reducing the cost. And yeah, so now I want to go to the meat of the presentation and share with you, what we learned, from running Argo CD for many years for various companies. And a lot of those learnings, we kind of translated back to contributions back to open source. So Argo CD, the latest version, usually has optimizations built in, and it's cheaper to run it. But some of those changes are not enabled by default, or requires additional configuration for like various reasons, for backward compatibility reasons. And so I'm focusing on this type of changes here. And it covers networking, compute cost, and basically a suggestion for you how to reduce the cost on a dedicated Kubernetes control plane server. And okay, so I want to start from the first lesson we've learned, the hard way. It has a short story behind it. So we, at our company, we run Argo CD for customers. And so one of the customers suddenly started costing us a lot of money. And we had to do some investigation to figure out what's happening. And what we learned is that we observed video streaming like traffic between application controller and control plane cluster. And I wanted to kind of highlight that it had nothing to do with how Argo CD is implemented. It uses very traditional approach of how all controllers in Kubernetes are implemented. So controller periodically update CRDs that it manages, in this case, application CRDs. In particular, Argo CD sent a tiny patch to every application, and patch usually contains bytes. It's like it changes the last reconciliation timestamp on an application, so it's literally bytes. And also, controller watches all the application, and this is where the problem appeared. So we learned that for some reason our customers had gigantic application CRDs. Basically, they were close to 1 megabyte, which is a limit of Kubernetes. And we had to understand the use case, why they were doing it, and we had to look for a solution. And so, I didn't explain why exactly 1 megabyte is a problem. So basically, Kubernetes API server, every time when it receives a patch request, it replies with the whole resource JSON. So in case of Argo CD, we have one watch and one patch request, and so every such request produces 2 megabytes of traffic. And with several thousands of applications, we did get to a level of video streaming, gigabytes per minute, and each gigabyte cost us a cent. And so we were paying several hundreds of dollars per day for one customer, so it was kind of a loss for us. And so we learned from our customers that they just wanted to deploy Helm charts, and Helm charts were sitting in a OCI registry. So for them, it was very easy to simply inline Helm values into the application spec, which is supported by Argo CD, and they had a lot of values that they had to supply. So it was literally several kilobytes, hundreds of kilobytes of value files. And Argo CD has a nice feature, rollback. And so to facilitate rollback, every time when you sync, Argo CD store a copy of value files used for a sync in a history. So we ended up having application resources with several kilobytes of value files stored 10 times in the same CRD. And yeah, so that was a problem. And we had to mitigate kind of the problem, we had to make a small change in application spec. So there is a feature of Argo CD that let you control how many versions you want to store in a history for each application. So we had to reduce it to 2. And our customer luckily didn't mind because they use GitOps for rollbacks. And next we started working with them to convince them to move those inlined values into a separate value.yaml file stored in a Git repository. And another feature of Argo CD called multiple sources kind of facilitate this transition. And basically, this is a a suggestion for you to watch and monitor the size of application resources in your control plane cluster. And so if you see that it's close to a megabyte, highly likely you're already paying a lot of money for cross-availability zone traffic within a cluster. And then next, we were not really happy because we had to work with the end user and convince them to use application in a slightly different way. We started to look for a more kind of permanent solution, and we found that there is a way to dramatically reduce number of times Kubernetes application controller patches application CRD. And so, to be very short, we introduced a setting which you can see here. I'm not sure if you can see my mouse. Setting is called controller resource health persist. It's in Argo CD, CMD params, CM config map. And what it does, it configure controller to stop storing health-related metadata in Kubernetes in application CRD. And that metadata is duplicated in Redis. And so unless you build something very specific around Argo CD application CRDs without using Argo CD API server, you probably don't even know this metadata exists, and it's very safe to just change this flag to true, and very likely you will reduce pressure on your API server, and it will really reduce the amount of traffic that controller sends to Kubernetes. All right, I want to move to the next suggestion. It's also related to traffic, and also related to large applications. Same story, we had a customer who suddenly started sending way more data, and we had to investigate, where is this data coming from and what's the reason. And so what happened is we learned that Argo CD had a kind of inefficiency related to applications that manage a lot of Kubernetes resources. And so if you have an application that creates single deployment, but deployment has hundreds of replicas, for Argo CD needs to visualize 101 resource in the user interface, because it kind of it tries to visualize everything, including pods. And so if you have such applications, then Argo CD updates a key in Redis, and it stores their JSON serialized a list of all those resources. And we realized that with the growth of number of resources, traffic grows exponentially. And the reason is, if you have a lot of pods, they change more frequently, and then every such change is bigger in size. And that's why we had a user who was managing application with like several thousands of resources, and it was again kind of video streaming-like situation. And so we've implemented an optimization and encourage you to consider enabling it in your cluster. So the setting is an environment variable, and the setting is fairly new, so there is no good default yet. But from our experience, we found that it's beneficial to use this magical number 50. And so what the setting does is it instructs controller to split information about application resources into chunks, and instead of storing them all in a single Redis key, now we can control how many resources go into a single key shard. That's how we call it internally. And number 50 showed the best results. So it doesn't overload CPU, so controller doesn't use much of CPU to handle reconciliations, and it really reduces the amount of data it sends to traffic. And then internally we noticed that in these extreme cases where you have large applications, it reduced traffic by like 10x, by significant amount. And finally, so we found that we had excessive internet traffic from controller to a managed cluster, and this is kind of, there is no really a good way to reduce this traffic. So there is no magical setting in Argo CD, unfortunately, but I wanted to suggest a workaround here, and the reason is this traffic is 10 times more expensive than internal traffic. And that's why even small optimizations here kind of translate to good savings. And so the reason for this traffic is Argo CD application controller watches managed Kubernetes clusters, and it tries to catch each and every event that happens and can potentially affect the state of managed applications. And so there are known resources that changes very frequently, and usually no one kind of care about those changes, and resources are endpoint and endpoint slices. And so by default, Argo CD manage and watch these resources because in some cases end users want to manage endpoints manually, but if you don't want to do it, then it's recommended to use a setting called resource exclusions and tell Argo CD to just don't watch these resources. And then that might save you tens of dollars per day, just because it's a significant source of traffic, and it just makes sense to do not watch these resources unless you really want it. And this is all suggestions I had about networking. And next I want to move to several lessons we learned about optimizing compute costs. And so one of the most impressive change we've made here on the screen. So as you can see, we changed one line in a Redis configuration, and it helped us to reduce our production in basically almost by 50%. And so what this setting does is, in HA mode, Argo CD uses Redis with a single master node and 2 slaves configured to replicate changes. And so there is a default setting in Redis called replication backlog size, which is set to half a gigabyte, so 500 megabytes. And it makes sense, I guess, for lots of applications. That's why it's a default. But Argo CD uses Redis as a throwaway cache, and we could not think of a single scenario where inconsistent replication might affect anything. So Redis is used only to visualize data in the UI, and it is anyways kind of has a little lag. So it shows you state of your Kubernetes cluster with a few seconds delay. So if it's delayed by another fraction of a second, nothing bad is going to happen. And so we changed it in all our instances to 60 megabytes, 64 megabytes, and reduced memory requests. And this is like a screenshot of the change we've made. So we used to run almost 150 nodes, and eventually number of nodes dropped from 150 to 80. And we were running around 100 Argo CD applications. So this is for you to kind of, if you run several dozens of Argo CD instances for your organization, there is a chance you can save hundreds of gigabytes of memory, and this change is safe. We can say it. We've been running this setup for several months now, and no complaints yet, and it's saving us $200 to $300 a day, which is pretty significant. All right, I have a few more suggestions, and we still have 7 minutes to go through them. So next, another frequent complaint and frequent consumer of compute is repo server. And so the reason is this component is kind of CPU heavy is it run for us Helm template commands and customized build. And those commands actually take a lot of memory and CPU. And another known problem is repo server is configured to, by default, it does not process multiple requests for a single application in a single repo. And the reason is sometimes there are side effects. And I would say historically, just in case, repo server is configured to only process one request at a time. And so in case you have a Git repository that has manifests of multiple applications, every time we make a single commit, Argo CD suddenly needs to regenerate manifests of all the applications in that repo, and it will handle every application one at a time. And so to provide a good user experience, you would be forced to run many replicas of repo server, and that's the waste of memory and CPU. And so the common suggestion we give to everyone and apply it to ourselves is we enable concurrent processing. And there is 2 well-known cases where it's safe, and that's why Argo CD has a kind of a setting to explicitly enable it. One is controlled by environment variable Argo CD Helm allow concurrency, and it in a new version 3.0 it will be set to true by default. If you run, I mean it's not yet released, that's why you for older version you would need to enable it by default, and we know it's safe, and it will save you. It will allow you to run less replicas of repo server and save some money. And another frequent reason where Argo CD sometimes have to run manifest generation sequentially is related to customize. So if you overwrite images in customized base settings and image is stored in application spec, then Argo CD have to modify files in a local clone of Git repository, and that requires to run manifest generation sequentially. So if you simply disable, if you don't use this feature, don't overwrite images, it will provide better performance and it will cost you less money. And last suggestion is once you enable parallel generation, you can use a parallel limits flag available in repo server to control how many manifest generation you want to run in parallel. And there is a very simple rule of what value you want to supply here. We found that it makes sense to check how much CPU cores and how much gigabytes of memory you give to your repo server instances, and smaller number between these two is parallel list limit. And the reason is it just makes sense to reserve one core for one fork exec of Helm or Customize, and usually every invocation takes 1 gigabyte. So that's what we use, at least internally. And last suggestion, almost on time. So we found that reserving and giving the whole Kubernetes cluster to Argo CD is often kind of a waste. And the reason is Argo CD uses Kubernetes API server simply to store a collection of applications, and it needs to get access to a few secrets and the config maps. And so if you provision a single Kubernetes cluster for each and every Argo CD instance that you have, it will not use a lot of features that production-ready Kubernetes cluster provides, such as different controllers, and so there will be some waste of resources. And internally, we found that it's beneficial for us to have a single host cluster for multiple Argo CDs, but we configure our Argo CDs to use K3s to store metadata. And this way, it's possible to use a single host cluster and have safely multiple Argo CDs with various versions using K3s clusters that runs on the same host cluster. And it did save us money because we didn't try to calculate exactly how much money we're saving, but I'm pretty sure we're talking about hundreds of dollars for each Argo CD instance. Okay, that's all I had, and we almost ran out of time. I'm using opportunity to talk about the book that our company sponsoring. So one of our colleagues and an engineer from Red Hat wrote this book. If you want to get it for free, I guess, yeah, that's available via this QR code. And thanks a lot. I hope this section was useful, and hopefully it will help you save some money for your company.